Hey everyone, welcome to Chemistry. Today we're going to look at the atomic structure. Under atomic structure, we're going to look at the structure of an atom and what it's made up of. So we'll define what an atom is. So an atom is the smallest particle of an element which takes part in a chemical reaction. Smallest particle of an element that takes part in a chemical reaction. So it's the smallest particle, and this particle is neutral of an element that takes part in a chemical reaction. So all the chemical reactions to occur, it means there is an atom. So the atoms are the ones that are involved in a chemical reaction. Now this atom has got a structure. So we're going to look at the structure of an atom. The structure of an atom has got what we call the nucleus. Then this nucleus is surrounded by what we call shells. So it contains the nucleus. And this nucleus is surrounded by what we call shells. So all these are called shells. Surrounded by what we call shells. These shells, we can call them orbitals, or we can call them energy levels. Okay. So it contains the nucleus. The nucleus is surrounded by shells, orbitals, and the energy levels. So these ones you can call them, if you want to use shells, if you want you can use orbitals, if you want you can use the energy levels. Now each of these, the nucleus contains what we call subatomic particles, and the shells also contain subatomic particles. So in the nucleus we find protons. So in the nucleus, inside the nucleus here, we have what we call protons and neutrons. Then in the shells, or these energy levels, are what we call electrons. So the protons are found in the nucleus, then the protons and electrons in the nucleus, the electrons are found in the shells. So in the nucleus we have the protons and we have the neutrons. Then in the shells or energy levels we have got the electrons. An atom contains the nucleus, which contains protons and the neutrons. The shells contain electrons. The protons and the neutrons, they are responsible for the mass of an atom, while the electrons are responsible for the chemical reactions of the atom. Meaning that for any chemical reaction to occur, the electrons must be present because they are the ones that are involved in chemical reactions. While the nucleus contains protons and the neutrons, which are responsible for the mass of the atom. So we have seen the structure of an atom, and we have said the nucleus contains protons and the neutrons, while the shells contains electrons. We have got the nucleus, so I've got two subatomic particles. We have got the protons, we have got the neutrons, and I've got the electrons. So the protons, they are found in the nucleus. The neutrons are found in the nucleus of an atom. The electrons are found in the shells, or the energy levels, or the orbitals. Then the protons, they've got a charge. So the charge on a proton is positive. The charge on the electron don't have a charge. These are neutral, so it is zero. Then the electrons have a negative charge. Then these, they have got also masses. So the protons, they have got a mass of 1. The neutrons have got a mass of 1. The electrons have got a mass of 1 over 1840. So these are the masses of the subatomic particles that are found in the nucleus and in the shells of an atom. So an atom contains protons, neutrons, and the electrons. The protons are found in the nucleus, the neutrons are found in the nucleus, and the electrons are found in the shells. So the shells, you can call them energy levels or orbitals. Then each of these subatomic particles have got charges. So protons, they have got a positive charge. Neutrons, they are neutral, they don't have a charge. Electrons, they have got a negative charge. And again, these subatomic particles, they have got masses. Protons mass of 1, neutrons mass of 1, and electrons have got a mass of 1 over 1840. Meaning that this is a very, very small number and the mass is negligible. That's why I've said that the protons and the electrons are responsible for the mass of the atom, while the electrons, they are responsible for chemical reactions. So all the chemical reactions, they occur because they are electrons that are responsible for their chemical reactions. So what are you supposed to know about the structure of the atom so far? You have to know that this atom has got the nucleus, and the nucleus contains protons and neutrons. And these two are responsible for the mass of the atom. Then the atom contains what we call shells, and these shells contain electrons. These electrons, they are responsible for chemical reactions. You also have to know the charges. That protons have got a charge of +1, neutrons have got a charge, no charge, so they write 0, they are neutral, and electrons have got -1. The protons and the neutrons have got a mass of 1 each, while electrons have got a mass of 1/1814. Okay, so now we're going to look at the atomic mass and the atomic number. So the atomic mass is simply the number of protons and neutrons in the nucleus of an atom. So here we've got the number of protons and neutrons in the nucleus of an atom. So atomic mass is the number of protons and neutrons in the nucleus of an atom. So the protons, when you add the protons and you add the neutrons, we'll get the mass number, which is called the atomic mass. Or we can call it the neutron number. So when you add the protons and the neutrons, we're going to get the mass number, which is the symbol is capital letter A. That's the mass number. So we add the protons and the neutrons, we'll get the mass number, because the mass number is the number of protons and the neutrons in the nucleus of an atom. Then the atomic number, this is the number of protons in the nucleus of an atom. So the number of protons in the nucleus of an atom. Atomic mass, the number of protons and neutrons. Atomic number, the number of protons in the nucleus of an atom. And for this one, we use the letter Z or Z as the symbol. So, meaning that when you add the number of atomic number plus the neutron number, we'll get the mass number. Now, in chemistry, we use symbols to represent the atoms. So most of the atoms, we find them on the periodic table. And the periodic table contains all the atoms that we're going to look at, their symbols, the mass numbers, and the proton numbers. We have said that the protons and the neutrons, when you add them, we're going to get the mass number. And the atomic number is simply the number of protons in the nucleus of an atom. So we have said there's a list of elements which is arranged according to the proton numbers, and that list is called the periodic table. So on the periodic table, there are a lot of atoms, and those atoms contain symbols. So a symbol in chemistry is not another symbol that people just make as gestures. In chemistry, a symbol is a letter or letters that represent an atom of an element. So let's give an example. If X is a symbol for an atom, it's going to have two numbers. It's going to have the atomic number, and it's going to have the mass number and the atomic number. So we have the mass number or the atomic mass, or we can call it the neutron number, the neutron number. The neutron number. Then this down here is called the atomic number or the proton number. So we have the mass number or the neutron number, then you have got the atomic number or the number of protons. So we have represented X as a symbol of an element. So each element is going to have these two numbers, the mass number and the atomic number. The mass number is always bigger than the atomic number, because for it to have the mass number, we add the atomic number plus the neutron number to get the mass number. So certain periodic tables, the mass numbers, they are down, the atomic numbers, they are up. So don't get confused, but simply just take the bigger one, that will be the mass number, and the smaller one, that will be the atomic number. So I'll give an example using sodium. So sodium has got two numbers. The symbol for sodium is capital letter N with a small letter A. We're going to have two numbers. We're going to have 23 and 11. So what does this mean? So the 23, this is the mass number. The 11, this is the atomic number. So the periodic table contains all these numbers. Each element there contains the atomic number, the atomic number and also the mass numbers. So we're going to have for sodium 23 as the mass number and 11 as the atomic number. Okay, so we have seen that sodium, by using sodium as an example, it has two numbers, the mass number and the atomic number. So we want to know how many protons, how many neutrons and how many electrons are found in an atom of sodium. So we have said that the atomic number is the number of protons in the nucleus of an atom. So what does it mean? That the number of protons is equal to 11, because the atomic number is the number of protons in the nucleus of an atom. Then the number of electrons, because we have said an atom is the smallest particle and you have said it must be neutral of an element. So an atom is a neutral particle of an element. So since it's neutral, it means that for an atom that is neutral, the number of protons is equal to the number of electrons. So the number of electrons will be 11. So the number of protons is equal to 11, the number of electrons is equal to 11. Now how do we find the number of neutrons? So we know that when you add the protons, small letter p, plus the neutrons, small letter n, you're going to get the mass number, which is n. So the mass number, we know it. The number of protons, we know them. So we have got protons is equal to 11, plus the number of neutrons is equal to 23, which is the mass number. So in order for us to find the value of n, which is the number of neutrons, we move this to the other side, so it becomes negative, so it becomes 23. You subtract 11, the number of neutrons will be equal to 12. So in an atom of sodium, we have got 11 protons, 11 electrons, and 12 neutrons. The number of protons and the number of electrons, they are equal in any neutral atom. If we consider another element like oxygen, the mass is 16 and the atomic number is 8. In this atom of oxygen, the number of protons will be equal to 8, which is the atomic number. The number of electrons will be equal to 8 because the number of electrons are equal to the number of protons, because this is the neutral atom. Then the number of neutrons, we just subtract the atomic number from the mass number, which will give us 8. So we have seen that it's very easy for us to get the number of protons, electrons, and neutrons from an atom, because you'll be given the mass numbers, the atomic numbers. We all get these from the periodic table. So the number of protons will be equal to the atomic number. The number of electrons will be equal to the number of protons, because we are looking at neutral atoms. And to find the number of neutrons, we subtract the atomic number from the mass numbers. So after calculating the number of protons, the number of neutrons, and the number of electrons, so the other question they can ask you is, show how the atom is neutral, because you have said these atoms, they are neutral. So they can ask you like, show how the atom of sodium is neutral. So how can you prove that this atom of sodium is neutral? So we started first by writing the charges of those subatomic particles that are found in an atom. So we said the protons is +1. The neutrons, they have no charge. Electrons, we said it's -1. So in an atom of sodium, we said the protons, they are 11. So multiply this by 11. The neutrons, we said they are 12. And the electrons, we said they are 11. So when you multiply +1 times 11, we get +11. Here we get 0. Here we get -11. When you add this, you are going to get a 0. So the overall charge in an atom is equal to 0, because this atom is neutral. So if you have been asked to show how an atom of sodium is neutral, it's very easy. We use the charges and the number of particles to show that when we subtract all these, the overall charge, it will be equal to 0. That's why an atom of sodium is neutral. So for today, we'll end here. Thank you very much.